All right, we're going to go ahead and begin our discussion with infrastructure services in the CCI collaboration, and we're going to talk about CDP first of all. Also LLDP we'll talk about. Now, what is CDP and LLDP? CDP is Cisco Discovery Protocol, and it helps you to discover Cisco devices, which kind of makes sense. LLDP is the same type of thing as Cisco Discovery Protocol, CDP, but it stands for Link Layer Discovery Protocol, and that's going to help you discover third-party devices or non-Cisco devices. So just two different styles of device discovery is all this really is. And it's going to be happening at layer 2. So you don't necessarily need to have any IP communication set up at all to make any of this CDP or LLDP work. And really all you need to do is look at the command show CDP neighbors, because it's on by default in your router or switch, and you'll be able to see what kind of CDP neighbors it sees, meaning what other Cisco devices are there out there. So, and this is going to be routers and switches and phones and things like that. So let's go ahead and actually move over to the slides and take a look at what CDP is here. So CDP, like I said, Cisco Discovery Protocol is what it stands for. Of course, we have to define the term before we can use it. There's so many acronyms here. It's going to be fun to keep track of them all, I'm sure. So Cisco Discovery Protocol, CDP. It is a layer 2 protocol, like we mentioned, for discovering devices, but it does use a multicast address at layer 2 in order to send out these advertisements. So it's not a broadcast, it's a multicast. So, and it's to that address down there, which is not necessarily important for you to remember for the lab, probably. It's just a nice piece of knowledge, maybe good for the written exam. But it also, the point is here is that it is useful for discovering Cisco devices, routers, switches, and especially phones. Phones is obviously going to be the top priority for where we're going to be using CDP most of all. CDP is going to be important for you to find, what port your actual phone is connected to. And it can also be useful for taking that MAC address that's assigned to that port, and now you can just copy and paste that into your configuration, which makes life a lot easier. You know that you've gone through the lab and you're gone through different exercises, and you've maybe fat fingered a key or two, typing the MAC address, and you're sitting there pulling your hair out for 30 minutes trying to figure out why the phone's not registering. Well, it's just usually a simple copy and paste error or a mistype in the MAC address. That's not usually, but one of the cases it could be. So here's an example of CDP, and I'm in the way here, so I'm going to just move out of the way a little bit. But you can see here that the show CDP neighbor command has displayed a switch, a couple phones, and also a queue module here. So it looks like we're on R3 in this example. The switch is going to be connected to gig 00 in this case. And then we have gig 021 and gig 020 connected to a couple phones. And also the queue module there on SM10, and that's service module 10. So coming back to the actual phones themselves, we're interested in the phones, of course. You see SEP, an extra credit for anyone who knows what SEP stands for, and we'll come back to that in a second. But we have, of course, the meat and potatoes of this is the MAC address, the SEP, and then MAC address at the end of that. So we need to take that MAC address and apply it into our configuration in some fashion. Of course, because the phone is going to be identified by the MAC address in CUCM and CUCME. So we have SEP, which stands for, you guessed it, Celsius Ethernet phone, which is a remainder from the Celsius days in Cisco. So Cisco, of course, bought Celsius, and that's how the products became Cisco phones. So anyway, we take these commands here to see the devices that we're connected to with CDP. This is such an underrated command too, because you really may not think of, all right, where's this phone connected to? I guess I got to trace the cable out or something. No, you can just use CDP and see where that phone's actually connected. Very easy to do. Now, the other part of this command that's very useful, because we don't really know what type of phone this is in the first place. We know that it is a phone because it is SEP, begins with SEP, but we don't know what type of phone it is. So if we use the command show CDP neighbor detail, and you can do that for a specific interface, like in this case we have show CDP neighbor FA1/0/11 detail, and that's going to give us the detail for that specific port on the phone. So we have a device ID, which once again, SEP, MAC address, And then we have, even an IP address for that device. So it looks like this one actually already got an IP address from the DHCP server, or maybe it's manually configured. Something maybe left over from another place. We have no idea at this point. We do know, however, that we have a Cisco IP phone and a 9971 phone at that. So we also, scrolling down through here, we see that we have the firmware version that phone is running, which is very useful as well, because if those firmware versions do not match in the Communications Manager server, then that means that the firmware either has to upgrade or downgrade from that point. So good to know what current firmware version that is running before you register it. It also will give you things like power drawn and power management information. Really useful information for sure for phone registration. And so we've got the ports now that these phones are located. The next section we'll talk about VLANs for actually getting those ports assigned to a specific virtual LAN. But skipping that for right now, let's move on to LLDP. LLDP, like I mentioned, is just the standards-based version of CDP. It's to identify third-party phones, third-party devices, non-Cisco devices. So LLDP, however, is used on some Cisco devices as well. For example, 7965s, 9971s, the phones that are on this blueprint will use LLDP by default. However, your switches, routers, things like that do not have LLDP running by default. So you would have to go ahead and turn that on to make that happen. So, like I said, this is a standards-based IEEE 802.1ab Layer 2 protocol for discovering neighbor devices. So like I said, primarily non-Cisco endpoints. LLDP-MED, Media Endpoint Discovery, is the thing that's actually going to detect that power and voice VLAN on the non-Cisco switches and allow that information to be passed into LLDP. So and I have here also the information is sent every 30 seconds and it has a hold time of 120 seconds. So that means that you have basically a packet going out saying, hey, I'm LLDP every 30 seconds, and then after 120 seconds that neighbor goes away essentially because it considers it down. And like I mentioned, it is disabled by default on Cisco routers and switches. Now the next slide here is going to show you just a sample output, and once again I'm going to get out of the way so you can see a little bit more of the sample output. So it is a show LLDP neighbors command, and we have, in this case, we just have a switch on all these different ports. We have switch on gig 00, switch on gig 020, and switch on gig 021. And you know what, it might be better to show you from the command line, so maybe we don't have to see all switches here. So let's pull up a command line real quick and have a look and see some LLDP. So of course, remember I said LLDP is not on by default, so we have to go ahead and enable that. I've done that already, but the command will be LLDP space run. That's it. That's all there is to it. If you do an LLDP space question mark, you can see you can change the times, you can change, the hold time, change the timer, decide what TLV values you want to send, type, length, and value. So from there, we can go to our show LLDP neighbor command, and we can kind of see what's connected here. And it looks like there is one phone, SEP, remember, in the rack in this case, in R3. So if we do a show LLDP neighbor detail, and of course we can do that for a specific interface if we want to define gigabit Ethernet 021, for example. We don't really need to because we only have one neighbor here. So we can just say show LLDP neighbors detail. And then from there we get the same type of information that we would get from our show CDP neighbors detail. And we have a Cisco IP phone, it's a 9971 again here. And this one's running firmware version 941 SR1-2, which I believe is the latest one as of now that you can get. We don't have any IP addressing information here on the chassis ID, so this one has not received any IP address from a DHCP server or manually configured at all. This actually happens to be one that's in the physical rack where the Proctor Labs racks are located, as opposed to being a local phone to me at this point. And one thing that you'll notice too on your home setups when you do your home VPN is that LLDP is not going to make it through that VPN. We're only tunneling CDP there. So CDP is the only thing we're going to be concerned about on the Proctor Labs side. So, but here's just a quick example of LLDP and how that looks. So let's head back to the presentation there. And once again, I show you here the detail for LLDP. So nothing different than what we just saw. Of course, we see a chassis ID at this point, so that's the actual phone IP address now. And we see a firmware version here again, and as well as the timer. So not a whole lot there that's different than CDP. Once again, the purpose of these commands are to see where the phone's connected, what type of firmware that phone has, and other, and also in addition to the firmware, the type of phone it is. There's also other benefits like seeing the IP address and things like that. So very useful command and very fundamental command before you start building your infrastructure. You can get an idea, kind of the lay of the land of where everything is at. So maybe you get a topology that says, hey, this phone is actually over here, this phone's over here, and then you look at your show CDP neighbors and it contradicts the topology that was given to you. Well, at that point, that may be something that was designed to trip you up, and now you figured it out because you know how to use CDP correctly. So definitely fundamental commands, basic information that you need to know, and this is a good start, a good building block for the rest of the lab. So the next section, what we're going to talk about is we're going to talk about some VLANs. We're going to talk about the rest of the infrastructure, of course, coming through VLANs, NTP, DHCP, so forth. So we will see you in the next video.